Good afternoon, everybody. Welcome to the March edition of our Controversies in Cardiology, the Ananda Sharma Visiting Professorship. This month, very special person, Joe Liscalzo, that Dr. Fuster will tell us about more. But it's not coincidental that he chose St. Patrick's Day to leave Boston and come to New York. The topic today is actually one which is near and dear to everyone's heart here at Mount Sinai, the role of HDL in atherogenesis. But before we start today and have Jonathan Feig, who's an expert in the field himself, present briefly on the subject, this conference, like all the other ones we do monthly, are carried on heart-talks.org on the web. Just to tell you which other talks we have archived just from this year. In September, we had Mark Cohen, who spoke about the controversy on a panel discussion led by Dr. Fuster on aortic stenosis. Our panel in October was with Spencer King on preventative coronary stenting. In November, Andrew Marks from Columbia. The controversy on the panel was beta blockade and heart failure. In December, William Stevenson, sudden cardiac death and coronary disease. January, Tony DeMaria, evolution of clinical cardiology. In February, Andrew Epstein from Penn on electrophysiology device therapy. And again, we're very privileged to have Joe Liscalzo today on the panel discussion led by Dr. Fuster on HDL and atherosclerosis. Let me just tell you a little bit about our moderator. Dr. Fuster serves as physician-in-chief here at Mount Sinai Heart and Mount Sinai Hospital. He is the Richard Gorlin, MD, Heart Research Foundation professor. He is the incoming editor of Journal of American College of Cardiology, the past president of the American Heart Association, the World Heart Federation. He is a member of the Institute of Medicine and National Academy of Science, and has been declared one of the few in the world legends in cardiology. I don't want to take up additional time from our exciting panel. So without further ado, Jonathan is going to give us a brief background on the subject.
Good afternoon. Welcome to Controversies. Today we're very fortunate to have Dr. Joseph Liscalzo here from the Brigham and Women's to join us in a very exciting topic, discussion on the topic of HDL biology and its relationship to coronary artery disease, the progression and the regression, the clinical trials related to HDL raising therapies, and where we go from there. But before we get started in the panel discussion, I would like to introduce the topic by just giving some points that I think are important to keep in mind. HDL, as you all know, is high-density lipoprotein. It's essentially considered good cholesterol, and it's a macromolecule consisting of lots of different proteins, but the most important one, apolipoprotein A1. Epidemiological studies have indicated that, in fact, there's a negative correlation between HDL levels and your cardiovascular disease risk, and that has led to a multitude of studies in vitro and in vivo to determine what are the atheroprotective effects of HDL. And they could be summarized in the following way. First of all, most importantly, I suppose one can argue HDL is considered a major player in the reverse cholesterol transport pathway, which is really comes down to the efflux of cholesterol. So it essentially picks up cholesterol from the peripheral tissues and brings them back to the liver. So think of it like a vacuum cleaner, sort of removing the cholesterol, or quote unquote the foreign object, and getting it out of the way of the vessel wall. But HDL also has other important features like anti-inflammatory, antioxidant, and also it protects the endothelium by upregulating, for example, the nitric oxide synthase. That's basically the in vitro world. But what about the plaque itself? What are the studies that has linked the HDL levels or HDL itself to the protective nature of plaques? And a tremendous amount of animal studies, both in mice and rabbits, have shown that indeed HDL, the expression of HDL or overexpression of HDL, can lead to the inhibition of progression. Very exciting really was in 1990 when it was shown by Badamon and his colleagues that actually HDL infusions can promote regression of plaques, and we and others have also demonstrated that elevation of HDL levels on a hyperlipidemic background can actually not only inhibit progression but promote regression. And by regression I mean it's not only decreasing the size of the plaque, but actually diminishing the macrophage content and increasing stabilization of the plaque by increased synthesis of collagen. So all of these points that I mentioned really is in the animal world, the mouse, the rabbit world, and petri dishes. But what about in the clinical realm? Well, in the clinical realm, a bunch of studies were done, and I summarized some of them in my manuscript, but I just want to highlight the Arbiter series of studies that essentially ultimately showed niacin, for example, which a drug that was FDA approved for the raising of HDL, was shown to have some beneficial effects using carotid intermediate thickness as a sort of a surrogate, although that in itself is controversial, but that's another topic. But keep in mind those studies, the Arbiter as well as the other ones, also included smaller amounts of patients. Very exciting in the clinical arena, though, was three clinical studies related to HDL and regression in a human population, and I summarized those in the manuscript as well. In brief, one of them was related to the infusion of ApoA1 Milano and looking at intravascular ultrasound, looking at plaques via intravascular ultrasound, and they showed somewhat a decrease in the atheroma volume. In the second study, in the ERASE study by Tardif and colleagues, they demonstrated recombinant HDL infusions also can demonstrate a trend, but it was not statistically significant for regression. In another study, which was more in the peripheral vascular arena, infusions of recombinant HDL led to thrombectomy samples from the peripheral vasculature, the superior femoral artery, and they demonstrated elegantly that they had a decrease in inflammation and actually a decrease in the macrophage content in these peripheral samples after the infusion of HDL. So of course, these all in all paint HDL as an atheroprotective agent, but what really, the story became much more complex when the bigger clinical trial with bigger numbers of patients, the AIM High, which had about 3,200 patients, and the HSP2 Thrive study, which had about 30,000 patients, really demonstrated a lack of efficacy in terms of the HDL raising strategy to sort of change outcomes. Now, both of those studies focused on niacin as the HDL raising therapy, but let me just mention one other agent that is very important is the cholesterol ester transfer protein, or CTP, inhibition trial, the Illuminate trial, this is another way of raising HDL via the inhibition of CTP, and it should be mentioned that in some trials that was led by Nir Barzilai, one of the experts on longevity, they showed that indeed CTP mutations in the population that had CTP sort of loss of function, so consider it sort of like CTP inhibition, those patients tend to have quote-unquote longevity. And there's also a Japanese group in Japan that also CTP inhibition was linked to a decrease in cardiovascular risk. So it was a surprise that in the Illuminate trial, indeed, CTP inhibition actually did not lead to the outcome they thought it would lead to. In fact, there was an increase in mortality. And the question over there was, is it a class effect or is it specific to that agent? And hopefully during the panel discussion, we will address that. So where does that leave us here? Well, I would say that on the surface, a superficial look at the data can suggest that the whole HDL hypothesis, it's time to put that to rest. I think that actually these are very exciting times, and maybe we just have to change the hypothesis, because what we now know, both from other investigators and myself, that it's the function that's important. And in fact, a recent study just came out that demonstrated that in human atheroma sample, there seems to be an increased expression of dysfunctional HDL because of the oxidation of the tyrosine residues. And by decreased function, I mean inability to remove the cholesterol. So you may have high levels of HDL, but it's sort of not doing what it's supposed to do. So in short, I would argue that it's probably the quality and not the quantity. So I look forward to an exciting panel discussion, and thank you for your attention.
Thank you very much, Jonathan. We have a very nice manuscript in a complex subject, which is the challenge for this evening. But anyway, I'd like to, first of all, it's an honor to introduce Dr. Joe Loscalzo to you. I know Joe for very many early years, maybe 25 years, since I met him for the first time. Well, he's close to New York when he was born. He was born in New Jersey, in Camden, and then he moved on very rapidly into what has been a tremendous success in everything he has done. First of all, in 1972, he was at the University of Pennsylvania, where he obtained a PhD degree in biochemistry. And then he moved to the Brigham and Women's Hospital, where he was resident in medicine, and then he eventually became chief resident there at the Brigham. Then he did his clinical fellowship, and eventually he moved to Boston University, where he became a distinguished professor of cardiovascular medicine. He was the director of the Whitaker Cardiovascular Institute, and then he became chairman of the Department of Medicine and physician-in-chief, as I mentioned, at the Boston University School of Medicine. Now he moved back to the Boston, to the Brigham and Women's Hospital, first a professor of theory, physician at the Harvard Medical School, and then he has a very illustrious career at the Brigham in the last few years. He's now chair of the Department of Medicine and is physician-in-chief of the medical center. Now, to go over his accomplishments, it would take me a long time. I can just summarize, for example, he's very well seeked by everybody. He has been the keynote speaker. I counted, actually, it took me half an hour, but he was in 40 different institutions. And then, perhaps most impressive is he has been the chair of very important committees, from the AHA Research Committee to the ABIM Cardiology Board for the examinations, NIH of the board, chairman of the board of scientific group there. He was head of the SCORE program for ischemic heart disease. He was the chairman of the Charter Society, of the Reynolds Foundation, and so forth. So he has been really very involved as chairing key committees at the AHA, NIH, and so forth. Now he has, in terms of professional societies, he obviously is the American Society of Clinical Investigation, American Physiological Society, many more. In terms of editorial boards, he became associate editor of the New England Journal of Medicine between 1995 and 2004. Now he's associate editor, Interactive Medical Care Series of the New England Journal of Medicine. Of course, we all recognize as editor-in-chief of Circulation since 2004, and he has been consulting editor of Circulation Research, Arteriosclerosis, Thrombosis, and Vascular Biology, and some others. Now, I cannot go over the awards, which are many, but are particularly interesting the ones from the American Heart Association, Distinguished Scientist Award in 2004, Research Achievement Award in 2006, Paul Dudley White Award in 2008, and he delivered the opening session of the American Heart Association, a Conner lecture in 2011. Now, in terms of funding and grants, very well funded from NIH and many others. And I just like to mention the one in 2011, 2015 in HLBI, the Pathophenotype Landscape of Complex Diseases, which is the PI, and most recently Boston Biomedical Innovation Center 2013 to 2020 with 3 other regions in the country, and he's the PI of all the medical centers in Boston for innovation and technology. So why all of this? Obviously, it comes because he's doing something right. So he has been a scientist, great cardiologist, very well known by his skills at the bedside. And as a scientist, he has been very involved with the endothelium, with all the properties of the endothelium, particularly nitric oxide, oxidative stress, and more recently, cardiovascular proteomics and complex systems and networks in biomedicine, as he presented today. So this is all the crystallization of a lot of work, which entails more than 700 publications, which I don't have to go into the details, but certainly relates to the field of vascular disease in general. And now he's in the genomic enterprise. He is also editor of the Harrison, the textbook. And anyway, I can go on and on, but I think I gave you a succinct summary of a huge success over the years, and it's a pleasure to have you here visiting with us today, Joe. And let me give you this plaque for you to remember your visit. And so Mount Sinai and all these titles here, Joseph Loscalzo, MD, PhD. I have to give you another plaque because they need the PhD. I will send it back to you. And for your outstanding wisdom and expertise, as you know, Dr. Sharma's father had an endowment to this lecture and the Simon Dack Memorial Lecture, which you remember Simon very well. I will this give back to you, but you can have it with you for the next hour, and then you return it. Okay? And this goes into your pocket. Thank you very much, Joe, for visiting us. And let's now go into the panel discussion. I'm going to call, obviously, Jonathan. And then we have here, I think we have Dr. Rosenson, Juan Badimon, Josh Dangas, Donald Smith. You can all sit. Joe, you can sit in the middle. Okay. Thank you very much. Appreciate it. Okay, thank you. Is Dr. Dangas here? He was not. All right. Okay, so let's begin by making few statements, and then we'll go slowly into the details. I think Jonathan mentioned that the protective effect of HDL against atherosclerosis is mainly attributed to the reversal mechanism of taking cholesterol from the wrong sides, certainly the arterial wall, as important to us in our specialty, and eliminating into the liver and the bile. That's one thing. But on the other hand, there's a lot of evidence that HDL does many other interesting things: anti-inflammatory, antioxidant, antithrombotic, anti-apoptotic, so a very pleiotropic action, which may explain many things when we talk about HDL. That's one aspect, is what is the function. So two different aspects. And the other second issue is the issue of the concentration of HDL, what that means compared with the function. And I learned this from Juan Badimon years ago. He has a very nice slide where it depends with the amount of apoprotein that is in the particle, the concentration will be more or less. So this is a very complex protein. That concentration really is interesting, but just the complexity tells us that the volume, the components of that volume may be different. And then we have the issue of function. So I'd like to ask you, Joe, and you know, these kind of discussions are really very quick, short answers and so forth, so we don't spend too much time, but what is your take of HDL today? Is a take of confusion, or you think is a take that as investigators we know very little and we have to explore? Is a take that this is probably a miracle molecule, which we did not find the miracle yet? What do you think?
I think that HDL has been oversimplified as a determinant of vascular biology, and it's been oversimplified in light of the way all the lipoproteins were first isolated by ultracentrifugation, flotation, and cholesterol content. And given recent data on the lipidomic and proteomic analyses of HDL particles, we know it's extraordinarily complex, much more than LDL. It's got over 100 proteins, probably more, that have been identified by modern proteomic techniques, and over 200 different lipid species. Metabolomic analyses, to my knowledge, haven't been done yet, but I imagine other small molecules that are not lipophilic will also be found in the particle. So given that complexity, it's no wonder that there is this inconsistency between animal models, human trials, and in vitro data that really reflects our ignorance, frankly, of the specific determinants of each of the phenotypic effects that are beneficial. So I think it's what we're facing is a landscape that is unknown, and that offers us lots of research potential for sorting out what the true determinants are of benefit.
Okay, thank you. I want to see. Hit the slide. Let me see if we can make it here. Yeah. Jonathan, this is a modification of your slide, and I think it's important that we go over for a moment, because there are all the critical issues, at least part of them, into the reverse cholesterol transfer process. So this is just to comment on, of course, this is a macrophage, and here this is this transporter that takes the cholesterol from the macrophage, free cholesterol, into this particle. And this particle, this so-called nascent HDL, is interesting because not only contains the apoprotein A1, which appears to be critical in the transportation of the cholesterol into the liver, but there are other issues in this molecule which are now beginning to be understood much better, which are a number of enzymes that do lots of things. Now here we have an enzyme which is actually in the circulation, and this enzyme, what it does, it moves the free cholesterol, L means rest of other lipid material, into esterified cholesterol. And then at the very end, this esterified cholesterol is delivered into the liver by two main mechanisms. One is a direct mechanism, which are the scavenger receptors here, and another is a mechanism which is the CETP that Jonathan mentioned, and that is this cholesterol that is esterified, it moves out through the LDL, and then it is being delivered. This is very important because when we talk about inhibitors, why you can inhibit something that is so good? And this is something we will be discussing later. But the basic point that I'm trying to make is this is actually one of the key mechanisms that HDL is involved with, and what is the concentration of this HDL is probably becoming less and less relevant, and what is becoming more and more relevant are the enzymes in the HDL, the amount of ApoA1, and a number of issues that we will be discussing later. So Jonathan, do you have any comments to make to your own slide, which is slightly modified?
The only comment I would make is that what this slide really demonstrated the complexity, and there's a lot of key players that we have to keep in mind when we think about HDL, and it really highlights that all of these key key components here have to be taken into consideration, and that's why function, the efflux ability of HDL is a critical component of its potential atheroprotective nature.
Good. This is just to present to you even more complex, because you move from pre-beta HDL, which is the receiver of the cholesterol from the macrophage, and it moves into other HDLs. And here is how this is how the free cholesterol becomes esterified. And it's just to give you a sense of the complexity of the process that we are really, or the processes that we are really talking about. Now, Joe, I'd like to ask you a question. I have been reading a lot about these new properties of HDL, and you really have worked on the endothelium. Now, we are told that HDL, aside of the reversible transport mechanism that we talk about it, has antioxidant properties, and in the endothelium does lots of things: antithrombotic, anti-inflammatory, anti-apoptotic, and so forth. I have not seen any evidence in humans that this is correct. What I have seen is ex vivo evidence, some studies in animals, but I'd like to ask you first after us, then I will ask Juan Vadimon about it. I just like to be convinced that these properties are really very well proven and have merit and perhaps work in vivo.
Well, there are a variety of features of the HDL particle that provide antioxidant protection. Those include small molecule antioxidants as well as enzymatic antioxidants. The key enzymatic antioxidant that people are most familiar with is peroxidase. And as it turns out, recent work that Stan Hazen's group has published suggests that peroxidase and myeloperoxidase both sit, if you will, scaffolded to HDL particles, and one offsets the effects of the other depending upon which is being specifically stimulated under certain conditions. Jonathan touched on some of the post-translational modification that can occur in apoproteins within HDL that can influence its benefit as a consequence of the lack of adequate antioxidant protection, but peroxidase is one of the antioxidants that's key. A second, as it turns out, just recently demonstrated in a proteomic analysis of HDL particles in humans, is glutathione peroxidase. And while you might think that it should be glutathione peroxidase type 3, which is the most abundant extracellular antioxidant peroxidase, it's actually glutathione peroxidase type 1, which is found within the HDL particle. And that's an important determinant of reducing peroxides on proteins and requires glutathione as a co-substrate. One of the glutathione peroxidases one would expect to find in HDL particles is glutathione peroxidase type 4, which specifically reduces lipid peroxides to their alcohols. But as far as I know, that hasn't been demonstrated yet. And then lastly, there are small molecule antioxidants like alpha-tocopherol, which are found in the HDL particle. So it's a rich milieu of targets for oxidation, of a source for oxidative modification, and of antioxidant protection mechanisms. And I would imagine that if one were to look at subfractions of HDL particles, one might find different distributions of those species in each, which makes this whole analysis all the more complicated in terms of sorting out what the beneficial particle subsets might be.
Juan, I suspect the milieu and the environment may change all of these factors that are really phenotypic in a way.
One of the things is that there are two evidences that if you give a high doses of HDL into humans, you obtain almost an immediate improvement in the endothelial cells. This was done by Roberto Corti in Zurich, and the problem is that you have to give a very high doses in order to see it. The other important issue is that the HDL also carries S1P, and this is a pro-survival protein. So this is important because if you have a dysfunctional endothelium, the presence of high levels of S1P, it may help these endothelial cells to survive. If you don't have the functional HDL, the endothelium goes down, and this is why you have all the problems. So basically, HDL is a significantly very complex lipoprotein, and as you said before, it's not the same thing to talk about HDL from Joe than from me, than from a patient with CAD, because this will respond to the environment where the HDL has been
In fact, we'll
manufactured.
discuss later, it's different if you have coronary disease or you don't have it, and the environment that you are. But so what we have done thus far is to talk in general about the reverse mechanism and the other possibilities that HDL can work. But then we touch into a second issue, which was the concentration of HDL may not necessarily mean that this is the function. Well, let's now discuss few studies, observational studies, that really point out what we are talking about. And the first one on the left is the Framingham heart study. Maybe Don. The Framingham, we are talking about the 1970s here, 1960s, 1970s, here on the top. And the question was very nice, isn't it? Higher is the concentration of HDL, more protection, and lower is the LDL, also more protection. And you could, was beautiful, with one caveat, and this came from Framingham, and still we talk about today, and that is that just one change of 1 milligram of HDL has an impact in mortality or in events of 2% favorable if you increase 1 milligram. If you decrease 1 milligram, it's 2% worse. Where in LDL, you really, is much less striking and long-acting. So now I want to ask you, Don, this is very nice, but it doesn't work, because the concentration today, as we are going to be discussing in a lot of detail, it doesn't seem, it's not because many of these people were obese. I mean, I'm giving you my explanation. Many of these people were obese, some were diabetics, were smokers, and HDL was no more than a manifestation of other risk factors that maybe led to the problem rather than HDL in itself. Is this possible?
It's very possible. And that those changes in triglycerides and HDL, the rising of the triglycerides and lowering of the HDL with insulin resistance, is a major epidemic sort of proportions today, which may be changing some of this older stuff when people were thinner around a bit. You can offset that by fortunately looking at non-HDL, which shows all of those. Basically, it takes the total and then subtracts out the healthy HDL, leaving both the VLDL and the LDL. And that's somewhat, I've found, very helpful. For example, in understanding the negative effects of some of the most recent trials, where really the non-HDLs are so pitiful, the difference, that you wouldn't expect to see any benefit. And this is an AIM high and an HPS2 Thrive. The 15 milligram per deciliter differences are less. You wouldn't expect anything, so it doesn't offset the fact that things that can raise HDL can be very important in terms of preventing.
So there are two aspects here. One, which we already alluded to, that perhaps what is important is the function. But the other aspect, again, is in these epidemiological studies, is that there are so many factors that are playing a role by which HDL moves one way or another, but it's the root of the problem what really makes this difference. And it just is important to look at. There is one trial that is telling you something, Dr. Rosenson, about the coronary drug study, which is the one that gave a lot of hope, if I recall, with niacin, which it is a study of secondary prevention. I think there were hundreds of patients, if I remember. It was about 16-year follow-up. And apparently mortality was decreased by the use of niacin. I don't know how people actually tolerated niacin at that time, and they do not tolerate it today. You might tell us whether it was a selective group of people, but tell us, because this is like, yes, Framingham may be right.
So the relationships between HDL cholesterol, and again, we're talking about the cholesterol cargo in HDL, not the HDL particle, and that's a critical, important factor. When the LDL cholesterol is high or in the background of weak statin, not relevant to coronary drug project, HDL cholesterol is a predictor of cardiovascular events. And the coronary drug project included individuals with very high levels of LDL cholesterol or total cholesterol. And niacin does have an LDL cholesterol lowering effect. And when compared to placebo in a very high-risk population, you would expect that lowering LDL cholesterol would reduce events. The situation changes dramatically if you look at AIM-high HbS2 Thrive on the background of statin therapy where the LDL cholesterol is already low, less than 70 milligram per deciliter. Increasing HDL cholesterol by about 31% doesn't seem to really make a difference with regards to cardiovascular event. So it's number one, it's a different era, it's a different lipid background, coronary drug project versus the more contemporary studies.
Are you telling, excuse me if I hear you properly, you're saying that the studies that we are going to discuss in a moment, statins were given, certainly two of them, and the LDL was very low, and maybe the effect of HDL was overshadowed. But are you telling us that you believe on the study, on the coronary drug project study?
Yes, I believe the results are due to the reduction in atherogenic lipoproteins. Niacin is effective in reducing VLDL, LDL, and lipoprotein a. The effects of niacin on HDL particles are minuscule, increasing at 1 to 2%. And there's no evidence that niacin per se improves the functionality of the HDL particle, as Karen Rader reported in JACC last year. So I think it's a reduction of atherogenic lipoproteins that's in play here.
Well, it's interesting. So you believe that still HDL plays a role through the niacin mechanism, and when the LDL maybe is not too low?
No, I'm saying that in the setting of a very high LDL cholesterol, that the benefits in the coronary drug project are due to the reduction in atherogenic lipoproteins, not the changes in HDL cholesterol, HDL particles, or HDL functionality. I think niacin's a loser in that regard. It cosmetically increases the cholesterol cargo of the HDL particles without expanding the pool of HDL particles, and it's been shown, at least using the Rothblatt-Rader method, there's no increase in macrophage cholesterol efflux with niacin, at least in a subset of the AIM-HIGH trial.
Well, I just present you the slide because I don't know if you understood Dr. Rosenson, but if you look how niacin works, it's impossible to understand. It works everywhere, and you don't know how much or how little. So I'm just telling you, this is a very interesting drug. Historically, it was given, but really there was no very clear evidence of what was doing. I just want to point out an historical point, just one.
But you raise a very important point. There is an article that when you talk about HDL, almost nobody refers to this article. It's by Paul Ridker. It's a sub-analysis of the Jupiter. And in the group that was treated with rosuvastatin, HDL was not predictive, and it was in the control. So this may support what you are saying, whether statins may modify HDL or statins by lower the risk, you don't see the benefits. But this is a paper from the Jupiter.
Well, there are two papers that really led to the skepticism, and this is the one that was already mentioned by Robert, which is the AIM-HIGH study in which statins were given together with niacin versus statins alone, and this is the results is actually exactly the same. There has been a lot of comments about this study because many people in the control group were taking niacin and so forth, so I don't want to make too much comment, but there is a second study that is also the one that is the HbS2 Thrive, which is very similar. Is that right, Robert?
Yes.
It's a very similar study in which niacin, in this case, is given with this particular drug that prevents flushing, laropipran, but it didn't make any difference either. Yeah. So in this study, they use a long-acting niacin, niaspan, I believe, and in the other they use that. So yes. Bad news, and the only thing that appeared to work following Framingham is this study in which, as Robert mentioned, maybe very high LDLs, HDL then shows some effect. Well, let's move into the further right, and this has been a great disappointment, and I like Don just to make a comment about the studies that actually block CETP. But I want to go back to the slide because there's something I don't understand it. Now, if the role of CETP is to remove the cholesterol, to give it to the LDL and here to the liver, I can understand that blocking CETP may increase HDL, but you're blocking the delivery of LDL. So can you explain it to me? Just looking at the slide, it seems to me that you're blocking something that is there for a purpose of defense, is to deliver the LDL into the liver. And you're blocking this, you're increasing the HDL, but still with the LDL inside, it's not the liver. So tell us what is the theory that this should work? Don?
Well, in terms of the theory, I mean, to me, the theory was unclear. In fact,
Well,
when
that's
these
enough.
were done, it seemed to me that you couldn't tell whether blocking that whole channel, in fact, would help anything. It would raise the HDL cholesterol rate, but it would not necessarily increase the reverse cholesterol transport. So the question is whether you can increase the direct transport through the HDL. I mean, I think that would be what I think they're asking. So, Robert, you may have a better explanation of why, theoretically, why this should be postulated as a better one. But I would have the same thing as you do, Dr. Foster, that basically, at the first, one could not necessarily tell.
So, Robert, we all understand HDL goes up when you block the dispensary, but the question is, you are not delivering the LDL in the place you want. So I don't think, and you get an HDL with a lot of LDL, and probably you are blocking even the function of the HDL.
Right, so with CETP inhibitors, you supersize the HDL particles and they carry ApoE. So the HDL particle actually may become pro-atherogenic and cleared by the ApoE receptor, that's present on the liver. Joe mentioned the differences in the proteome and the lipidome as a function of HDL subclasses. The smaller subclasses contain a more rich antioxidant, anti-inflammatory proteome and lipidome than do the large particles. So when you supersize the HDL particles, you're changing their function. They don't always become dysfunctional because they still work through the ABCG1 transporter, as Alan Tall has shown for decades. But some of the other critical properties, the critical functions, are lost with CETP inhibitors. And CETP inhibitors are an example like niacin. The particles become so heavily loaded with cholesterol, but the number of HDL particles increases with torcetrapib by only 1%.
Yes, Juan.
I think that I am more simplistic. CETP inhibitors, they do not block HDL. They block the transfer of the cholesterol carried by the HDL. So this is why you have the same HDL. And when you make it a very fluffy, very cholesterol-rich HDL, and probably it's proteinogenic, but you don't change the particle. So you stop the transfer of the cholesterol carried by the HDL. You do not affect the HDL.
Joe, we are going to get into the mechanisms that lead to high and low HDL, and then we'll get into therapies. But based on the discussion we just had, I learned some time ago from somebody that when you have a low HDL and you cannot move it up, you lower the LDL as much as possible. Now, so the effect is on the LDL, and you do nothing with the HDL, which probably, when the LDL is low, the LDL takes care, or the low LDL takes care of the function. Is this your understanding? Let's assume I present to you a patient with an HDL of 27, and then the patient has an LDL, let's say, of 160.
Right,
and you cannot raise the HDL.
Right, so drive the LDL down as low as you can, and that generally provides a milieu which will modestly improve the risk of atherogenesis. I mean, ideally, you'd like to get the HDL up as well if you have established disease in order to help facilitate regression or at least stabilize plaque. But I think you're right, you get much more bang for your buck for reasons that exceed those of LDL lowering per se by statins, which are influenced largely by the so-called pleiotropic effects of statins that you're all familiar with, anti-inflammatory among them. So that I think that has clouded the picture. I'd also just make a comment to the comments that have been made already around CETP inhibition. I mean, these are artificial situations that are created by inhibiting CETP. While there are experiments of nature in which there are absent or abnormal or deficient CETP enzyme, the situation that we create by giving CETP inhibitors is one in which there are different kinds of populations, probably with different subpopulations, which themselves may have different degrees of benefit, as Robert was suggesting, based on the size and the difference in concentration of antioxidants in large fluffy HDL particles. So I think we have to be careful in focusing on a single measurement or a single metric as an index of the benefit of these drugs. Let's forget the other issue around torcetrapib, which has to do with off-target effects in activation of the renin-angiotensin system, which is a separate issue.
Yeah, thank you. We'll get more into the details of these. If you have a normal LDL, 70, 75 done, and you have an HDL of 30, what do you do? In other words, and you have trouble in raising the HDL, do you still believe into what was discussed a minute ago?
I'm not sure, because again, if you're down that low in terms of 70, you don't have input of that a lot of proteins to make more atherosclerosis. Those are sort of cases where you have to look at least clinically at family history, and then I use the coronary calcium scores to help me sort of assess whether that's a real problem in terms of least plaque burden. So in general, yes, those patients would have much more than you would expect in terms of age and gender atherosclerosis.
Okay, George, let's go. Let's get now into the issue of what raises HDL, what lowers HDL, and how we are going to manage our patients, and what is in the future in front of us. Now, you are in the cath lab, and you see lots of patients with these lipoproteinemias and lots of patients with low HDL. Actually, in our Freedom study, I can say that 80% of the patients were obese, and 50 to 60% had a low HDL. So it's not the first thing we should pay attention to. Obesity, the issue of exercise, smoking, and so forth, which we will discuss in a moment, before we get a torture into our brains what drug we are going to give.
I think, the Freedom example that you use is a very great one, because everybody in the study was diabetic. And among those diabetic with significant CAD having a low HDL in the baseline, that's not a good thing. Definitely not a good thing. And I think our empirical impression is that the outcomes of revascularization by PCI when the lipids are and the diabetes is completely out of whack, they're really not very good at all. And perhaps these particulars with the low HDL and the unfavorable profiles with obesity and all that, if they don't get modified over time, they erode the durability results of the PCI by creating inflammation and other things that ultimately will produce target lesion failure in one way or another, probably by extensive restenosis or by repeated MI and all that.
Okay, Jonathan, here's a question for you. I will read you 4 statements made by guidelines, which have to do, 1 about exercise, the 2nd about weight loss, the 3rd about the smoking cessation, and the 4th about alcohol intake, and all in the context of HDL, okay? And let me see how you react. About exercise, regular moderate intensity activity increases HDL levels by 5 to 10%. Now, if you do exercise at least 30 minutes, If you are obese, you should do exercise daily, 5 days a week, 60 minutes. And then you reach these levels. This is about aerobic exercise. In terms of weight loss, for every kilogram that you lose, you increase 0.35 milligrams DL of HDL. Very impressive, the role of weight. Smoking cessation. Smokers tend to have an HDL level that is 5 to 10% lower than match controls. And therefore, the issue of discontinuous smoking is also important. The troublesome situation is about alcohol. Alcohol consumption can increase with 2 glasses a day, 2 milligrams DL of HDL, which progressively goes up over a period of few months. So based on this, Jonathan, is not correct that we should pay, at least in our degree of knowledge today about pharmacology and all what we discussed, should we pay more attention to these aspects?
I think it's very obvious and very clear that lifestyle modifications really continue. Oh, thank you. I think it's very clear that lifestyle modifications are really the #1 priority, or should definitely, in my opinion, be the priority whenever we deal with any of these patients, quite frankly, regardless of their lipoprotein profile, simply because of for their health. I mean, we know, just like the numbers you indicated, that if you sort of do the exercise and stop smoking, you're going to be better off. And so it's true. We can talk about the pharmacology from today and tomorrow, but you know, they're not going to take their pills if they're not going to do something simple like stop smoking or exercise. So I think we have to emphasize that stuff. And the pills, you know, is a different aspect. But the reality is, and I think you make a very important point, that we as physicians and healthcare providers do have to really emphasize more about lifestyle modifications and healthy living.
Robert, do you think that what we are doing here is improving that particular individual? Do you think the function of the HDL is also improving, or there's any data? What we are talking is about concentration, but nothing else.
Yes. There's data from the UCLA group that shows that weight loss and moderately intense exercise increases the functionality of HDL particles. They become more effective as antioxidants or protecting LDL against oxidative modification. So there are functional aspects as well, and clearly we know that cigarette smoking, through all the different toxins there, can impair HDL functionality, you know, in terms of affecting endothelium, and, you know, smoking cessation can improve HDL cholesterol levels as well as the functionality of those particles. So yes, that data does exist.
Joe, what is your feeling about the change in lifestyle affecting the concentration of HDL and therefore having a better prospect?
I think the lifestyle changes that have been recommended will, while having a modest effect on total concentration of HDL cholesterol, will have a greater effect on improving function. So if we had an index of function, the net effect would be far greater from these modifications, most notably weight loss and smoke cessation. And just add to the smoke cessation comment, among the specific toxins in smoke, there are those which can post-translationally modify functional groups on apoprotein A1, which can render it less able to facilitate reverse transport. So it's got a very direct effect on 2 methionines, which have an adverse consequence functionally. So I think all of these points speak to the importance of sorting out a true functional assay. And I would suggest that it's not just a functional assay of a population of HDL particles, but some better way to fractionate the HDL particles to identify those which are the most functionally important and likeliest to have the greatest benefit.
We'll make few comments about the drugs that we use, and then we'll go into what is new and exciting. Okay, Don. Niacin. The patients have flushing, and you still can use it in specific groups like lipoprotein elevation, lipoprotein A, high triglycerides. And what do you do? Is this true that aspirin helps? Is this true that to avoid alcohol and hot liquids help? What do you do?
Well, in fact, it is true. You have to use enough aspirin. That would be the 325 as opposed to 81. That will definitely prevent a lot of the side effect. And it's funny, you figure out how does spicy foods and stuff do it, and yet you get people in who have exactly that phenomenon, that they've eaten spicy foods, and therefore they have these things, and they stop them, and they don't have them. So those are ways, basically, to get rid of those and be able to use niacin. What was the other part about the question?
Well, no, we're talking about the aspirin to avoid stuff that really causes vasodilatation. That's really what we were talking about. Now, there are issues that we face every day. That's why I was asking to avoid flushing, that's all. The other question is about fibrates. It's interesting. The issue of fibrates that we face very commonly is what happened with the statins. And that is myopathies and leg pains and muscle pains and so forth. Is this your experience, Don? Just with fibrates?
The combination, does it increase muscle pain?
Even fibrates alone. You are looking with a statin, the patient has problems with pains, muscle aches, and so forth. You move into a fibrate, and you end up with the same situation. At least this is my experience and of many others. I wonder if you or maybe you, Robert, can comment on.
Well, I hate to move into a fibric acid, so I'll do anything to be able to use the statin. And so you can choose many different ones. There are some now just published in the Annals where they've taken people who have 3 weeks onset of myalgias, and then they've done a placebo-controlled trial back and forth for 3 weeks on a placebo and on their own drug to see if they can tell the difference. And there's no statistical difference in what they feel on those two, whether it's placebo or on the statin. So it's a strange thing, and you have to back away from it to make them feel that you're listening to them. But basically, you're trying different other statins, mainly the longer duration statins, such as atorvastatin, rosuvastatin, fluvastatin XL, or less called XL80. Those you can use every other day. That helps tremendously in terms of reducing down the side effects, and yet being able to get some sort of major lipid effect.
Robert?
Phenofibrate can cause rates of myalgia and myositis that are the same as the statins. One of the trials that you didn't talk about, just to stir it up, is the VA HIT trial. You know, men with coronary disease, MI, who had low levels of HDL cholesterol, gemfibrozil, different from phenofibrate, increased the concentration of small and total HDL particles, and that was a significant predictor of a reduction in cardiovascular events. It explained 55% of the benefit in that trial. So the fibrates don't increase HDL cholesterol that much unless the triglycerides are elevated, but it's the increased number of small HDL particles that may be quite important.
Okay, yeah. Let's move into the future right now, and let's, we have discussed the problems that we have with concentration of HDL and the question that function can be of interest. Before we go into the function, I would like to touch into one or two subjects. First, the CETP inhibition. It seems to me there are a couple of trials still. The first two studies done, they fail, and I don't have to go into the details. One, it failed because maybe the renin-angiotensin system was activated. The other failed, who knows why. But what do we have in the pipeline, Robert?
There are two studies undergoing. One is with anacetrapib, the REVEAL trial, 30,000 individuals conducted by the Oxford group, and then the evacetrapib ACCELERATE trial, post-ACS population. CETP also lowers LDL cholesterol and reduces ApoB LDL particles, and at least the REVEAL trial was appropriately powered based on its LDL cholesterol lowering effect. The issue is whether these two CETP inhibitors will work because they lower LDL cholesterol, and whether the benefit is better than anticipated by the reduction in LDL cholesterol from the cholesterol treatment trialists, that regression analysis, or whether the benefit is more or less, and that would be an issue of whether the HDL particle is functional or dysfunctional. And I think sorting that out is going to be very interesting when those trials are completed.
We needed 2 to 5 years, isn't it, to have the results?
Yes.
Thank you. Jonathan, let's talk for a moment about one issue, which is DPOE1 Milano, which to me is the most clear example that concentration is not important, but rather function. The DPOE1 Milano is a mutation that takes place in the DPOE1. Cholesterol HDL levels are very low, and the patients are protected. This is not the best example that we have about HDL concentration meaning very little compared with function.
I think that study really illustrates the fact that the concentration of the HDL it doesn't really give you the full story, but rather the function. And many studies after that have shown, for example, by P.K. Shah and colleagues, they've demonstrated where the injection of the ApoA1 Milano, even in a mouse model, can cause rapid regression, suggesting that there is something to say about the ApoA1 Milano, simply because of its ability to efflux the cholesterol and among its other pleiotropic effects. But it seems to be that the function is highlighted there. So it's a very good example.
Joe, let's talk about function for a moment. You know, what is everybody talks now at this time is you put a macrophage here, you put the molecule of HDL here, and you measure how the LDL is secreted. Now, do you think, it seems interesting, we don't have a lot of information yet, but it seems interesting, but suspect function is much more complex than this, is not correct? We are talking about function is the future, but tell us what we are talking about.
Yes. Well, the conventional assays that people use to look at reverse cholesterol transport involve using radio-labeled cholesterol species and looking at flux rates. And the problem with that is it doesn't get at mass. So really the best way to determine the benefits, at least with respect to this specific aspect of function, is to measure mass. And there's some clever ways in the literature that people have used to address that specific question in animal models that involve encapsulating macrophages, for example, in nanofiber tubes that can be used as a way to remove and assay total cholesterol content. These are cumbersome assays. They're fine from the perspective of drug development, but to assess in a clinically relevant way the function of a population of HDL particles, it would be rather challenging, expensive, and time-consuming. So we're in sore need of better, and perhaps the other folks in the panel will know much more about this than I, but we're in sore need of better assays that are simple and straightforward to assess the critical functions that we think are important. Now, what are the most important functions? We're focusing on reverse transport. Maybe there are other aspects that are more important. Maybe sphingosphene 1-phosphate content would be important because of its anti-apoptotic effects. Maybe antioxidant assays of enzymes of note, some of which I mentioned earlier, would be important. And I think ultimately we're going to need to have some kind of index or profile of several key functions of the HDL particle that can guide us with respect to future drug development and risk.
Thank you. Juan, you have been working, actually you were the first who injected ApoA1 in the rabbit model and was quite successful. Now I like to look at the possibilities that we have in using something so poor like ApoA1, okay, being injected. Some of the problems, I believe, is very short-acting, and you have to give lots of injections. But it acts very rapidly, at least in the animal model. Is not correct. The statins take a year to do something to the plaque, but this ApoA1 may take a few hours to really make a difference. Tell us your view about the possibility that we have ApoA1 injected and why the trials were stopped. Was an economic issue or what? Just tell us.
Yeah. First, talking about the mechanism of action, so let's forget the animals and let's go to humans. I mean, if we evaluate the study done by the Cleveland Clinic, as you said before, 5 single injections were able to regress a coronary plaque assessed by IBUS 1.4%. Probably you are saying that this makes no sense. 1.4, who cares? But then you go to the other study. The landmark study that generated the idea, the lower the better. It was the study done in that time by Topol, and 18 months of atorvastatin 80 reduced 0.4% the plaque. in humans in a study done also by the Cleveland Clinic. So basically, this clearly illustrates what you are saying. We don't care about having HDL cholesterol falling around in your body. What you want the HDL is to do what it's supposed to do. And among other things, one of the more important things is the reverse cholesterol transport. And my personal opinion, even though there are pleiotropic effects, but let's be functionally, if you have cholesterol in your vessel wall, cholesterol is pro-inflammatory and cytotoxic. And this is going to trigger a series of bad reactions. If you are able to reduce the pro-inflammatory stimuli by removing cholesterol from the wall, you are doing all these things. You improve endothelial dysfunction, you are anti-apoptotic, you stabilize prostacyclin, and I think that this is why we see pleiotropic effects associated with the statins and associated with HDL. The other thing is when you give ApoA1 Milano, you don't give ApoA1 alone, because cannot be. You already give with phospholipids. And in the moment that you inject it, it takes few seconds for the ApoA1 to become the real HDL. But we also have another clear evidence. When you take your own autologous HDL, this is a study done by Brian Brewer, so to avoid any potential immunological reactions, you take your own HDL, you pass it through a columns, you deplete the lipids, and you inject again, like you said before, the nascent HDL, so you are able to have a significant benefit. And in fact, one study done by Waxman in Washington, when you put the two studies, the one done by ApoA1 Milano and the one with the delipidated HDL, they are almost identical. And this is humans, and this is with IBUs.
Well,
and
this
again, indicate what you said before. We need functional HDL. We don't care about a lot of HDL because of the
okay,
CTP.
so this is important, but the question I'm asking is why these studies are being stopped.
The big problem with ApoA1 Milano, the last time that I talked to one of these persons, it cost about $30,000 an injection. Because sometimes...
You need many injections, so you have to be really
because
rich.
It seems, and again, this is a lot of confidentiality and things like that they don't tell you a clear answer. It seems that you have to really extract it from the cell. And then you have to do a lot of purification steps. And the more purification you do, the less efficient you are, and this is why it's so expensive.
Joe, are you into this? That the issue here is we are really working on purify or even synthesize ApoA1 and so forth. Do you think this could be interesting in the future, or you think it will not be feasible because the expenses or because you have to give injections? But in acute syndromes, maybe 5 injections is enough. So what is your opinion about the future of this approach?
I still have some hesitancy about developing a very expensive and therapeutic strategy on the basis of such marginal changes by IVUS in plaque size. Admittedly, you can extrapolate, but I'd like to see stronger data in that regard. And it may, if those data were forthcoming, you might argue this is an ideal situation in which you could use gene therapy approaches, which are becoming simpler, safer, more durable, less expensive in the future, especially since you wouldn't mind if the gene were only expressed in the liver, where it should be expressed. So if you wanted, if you got round the immunologic problems, which might be possible, that might be one approach. But I still remain somewhat skeptical of the long-term and global benefits, especially in individuals who have established complicated plaque with lots of fibrosis, calcification, and so forth. Elegance of careful quantitative IVUS notwithstanding.
Jonathan, your view about purification and injection?
I think there's still a lot of more biology that we need to define in this field before we, sort of jump in and going into, full-blown injections. Because I think the slide behind me illustrates that there's a lot we don't know at this time. I think what we do know, though, is that we have to figure out a way, an assay that can be somewhat commercialized in order to get, measure the function, the functional component of HDL in a sort of quote-unquote a realistic manner, because then we can start potentially taking all our patients that we do lipid profiles on, getting an index of function, and then really having quote-unquote the power to statistically observe if the functional aspect of HDL is related to other factors. And so I think, based on the data we know thus far, it definitely, the levels of HDL does not give us the full story. It appears that the function of HDL is certainly more important. But how we approach it, I think it's still in quote-unquote discovery mode.
Yeah. Robert, I have a hypothesis about this future. Personally, it's like, with everything we know about obesity, smoking, statins, and so forth, HDL lowers its interest, except when one situation is the acute effect that it may have in situations that are acute. So I only give you this for the discussion. My hypothesis is we probably should forget about HDL. I'm sorry to say this in this way, but it's just for the discussion. And perhaps to pay attention not on the chronic aspects of HDL, but in the acute aspects. If there is any value, once we have all the other aspects that are probably solving great part of the problem.
Well, patients with ACS clearly are at higher risk, and we know that in that situation that at least A1 Milano, very small study, can reduce atherosclerosis. Again, we don't know whether it reduces events. The Brian Brewer's delipidation technique works very well in these individuals. Again, regression of atherosclerosis, whether it reduces events, we don't know. Some of the recent literature from the Cleveland Clinic and the University of Washington, are showing dysfunctional HDL in ACS individuals, that these ApoA1 is being affected by myeloperoxidase and generates a particle that's actually pro-inflammatory and one that interferes with ABCA1 transport, which is a quintessential transporter for macrophage efflux. So it may be that in the ACS population you could overcome the potential hazards caused by myeloperoxidase, but that's certainly going to require a lot of work. There are imaging studies that are ongoing to look at the hydroxytryptophan moiety that Hayes and his group recently reported in Nature Medicine, and it appears to localize in the areas of the vulnerable plaque, and whether it predicts events is something that they're looking at in ongoing trials. So we have a lot more to do. I'm not going to abandon HDL because then I'd be pretty bored with my career.
Don, I know you will not abandon HDL, but should we pay more attention to triglycerides? Because the drugs we are using, they are very effective on triglycerides, and the issue of postprandial risk of high triglyceride is becoming in the literature as a big hit. Should perhaps pay more attention to these drugs on the triglyceride level, maybe to do blood sampling after meals, than just so much of a torture of HDL, which we have been over the last 40 years.
Well, I think the studies show that if you look at postprandial triglyceride levels, they have the same adverse effect, basically as if they are in the fasting state. So you can use those to look at risk. On the other hand, if you're trying to treat them and manage them, you have to have the constant state of fasting to be able to see any sort of therapeutic effect that you're trying. But that original question with the HDL of 30 and LDL of 70, there are two different scenarios. If you have high triglycerides with this, then it's just simply horrible. On the other hand, if the triglycerides are much more in the normal range, and under 150, it's not quite so bad. So the whole triglyceride, low HDL thing is part of the whole epidemic of coronary disease, and certainly we have to pay attention to it. The question is, how do you pay attention to it? And one is lifestyle. Lifestyle is the most effective way of triglyceride.
I'd like to ask George, actually. George, give us your overall view of the discussion that we had today, in which of a molecule that we have been struggling for so many years, and now maybe others are doing the job, and we are talking lifestyle, we are talking about triglycerides, we are talking about statins, we are talking about everything around it that may be more important. Is this your view?
Well, I think I will stay at the very positive thing that we discussed regarding something we saw and sounded like the finances weren't right to capitalize on it, and this is the ApoA1 injections that rapidly stabilize the plaque, and I wonder if those could be revisited in the aspects of acute coronary syndromes and improvement of outcome in this way. when the people are really needing a big surge up front and then fall up later on. So I think that would be more plausible, not impossible at least, and it doesn't seem that we've gone a long way with the chronic studies we've done in these types of patients.
Thank you. Questions or comments? Yes, please.
If you allow me before, because people usually, we always compare the M high and the HPS2. They say, oh, the combination of statin and niacin didn't work. There is a point, from the pharmacological point of view, when you go to the HPS2, it was something else that is called laropipran. And when we discuss, we assume that laropipran was innocuous. And remember, this is an inhibitor of the prostaglandin D4 receptor. And we have a history that when you fool around with the prostaglandins in cardiovascular, you may have more infarct. So we have to be careful when you use the HPS2 to deauthorize the possibilities of HDL. It doesn't mean that it will work, but you have to be careful because we have three components, and one of them we're assuming that it's innocuous, and probably it's not.
Yeah, Dr. Friedman?
Yeah, I was reading this review, Cardiosource, about remnant lipoproteins, and buried in there someplace, the author said that the LDL leaves the HDL because of CETP, but is a transfer of triglycerides back into the HDL. Mm-hmm. And then he went on to say that that changes the HDL's enzymatic properties and results in the liberation of lots of small LDL. And it just seemed like it was approaching a unifying hypothesis, if it's true, not that I know what he was talking about. And the other thing I wanted to ask, if there's anything about intestinal fat and free fatty acids, and if the free fatty acids postprandial have anything to do with poisoning the system.
Any comments, Robert?
Yeah, so what you're talking about is related to the CETP pathway, which accounts for 60% of the HDL cholesterol. The triglycerides, get shifted from VLDL to LDL and VLDL to HDL, and the functional properties do change, and triglyceride-enriched HDL is not as effective in mediating macrophage cholesterol efflux as a particle that's more cholesterol-rich, at least through SRB1 and ABCG1. And the second part is about the remnants.
Free fatty acids.
Oh, free fatty acids.
What they do to the endothelium and postprandial state.
Yeah, free fatty acids can become, oxidized and, can cause endothelial dysfunction. And many of the moieties are pro-inflammatory as well.
Any other question or comment?
I think that in Greg Brown's HATS trial, he used much higher doses of niacin, 3 to 4 grams. Is it possible that we're simply not using enough?
Realize that the maximum effects on HDL cholesterol are at really 1 gram, per day, and higher doses are reducing atherogenic lipoproteins, including lipoprotein little a. So in the HAT study, when he discussed lipoprotein little a becomes unimportant, when you lower LDL cholesterol less than 70, you have a drug that lowers LPA and it lowers atherogenic lipoproteins, including LDL cholesterol. So that, conclusion I think was somewhat, flawed. We just don't have any good evidence that niacin's effect on increasing HDL cholesterol is favorable in terms of functionality. And the number of HDL particles increases by, 2% only. It's probably not enough to make a difference. And as we talked about, the characteristics of the lipidome proteome change dramatically as these particles become cholesterol loaded.
Any other question or comment? Yes.
I see that macrophage, and that's where it works. If you lower the LDL intensively, it's been shown, and Peter Libby and others show, you get rid of the macrophages. So after a year, the HDL comes along, there are no macrophages. Where does it take the cholesterol from? Does it take it from the lipid core, or is the only way it can take it is from the macrophages? And you lower the LDLs, the macrophages go away. So therefore, maybe after 2 years of intensive LDL, you give them HDL raising, and the garbage trucks have no place to pick up the garbage.
Except when statins do the job, but still you have a significant number of events. So one of the issues about HDL it survives because you are not getting rid of the problem completely with the statins, whatever the mechanism is.
Yeah, clinically, what the people usually says is that when you give statins, you inhibit the progression of the plaque. You have to be very aggressive in order to decrease the plaque size. And where is the lipid coming from? Theoretically, if you look here, you need certain receptors. So it is assumed that the cholesterol is removed from inside of the macrophages, not from the necrotic lipid core. What happened that if you decrease the amount of lipids, and you remove it from a macrophage, this macrophage that was full of lipids now is emptied, it's going to eat some from the. But remember, it takes a long time. And if you work with the statins, the problem is you stop the progression. That is good. This is why you reduce 40%. But there is still a 60% of events that you cannot prevent.
Joe, I'd like to ask you for a final comment, and that is, at least if one summarizes what we heard today, is number one, and you made this very clear, function is essential. And the function is not only the cholesterol transport, is all the other functions, vasodilatation, endothelium, and so forth, that we talk about it. That's important, and how this is measured in the future. But it seems to me that we have to move into the acute effects of HDL rather than the chronic effects if we are going to make a significant difference in this disease. And I'd like you to comment about that second aspect, because I didn't hear you to comment about it.
I think the data are more compelling about there being a benefit in the acute setting, as we discussed earlier. So there is an advantage to trying to move forward in that light. But I also think that if, in light of what's happened in animal models, we need to know something more about the intermediate term effects, not simply forego them. And it's true that calcified plaque isn't going to regress or remodel once you remove the lipid-laden macrophages from it, at least not significantly. But given the complexity and the heterogeneity of plaque in a patient with established disease, while you might administer some HDL elevating therapy or apoprotein A1 Milano itself, for example, in the acute coronary syndrome setting, there's still a longer-term benefit which can, I think, optimize and stabilize those plaques which are not yet ripe for activation. So perhaps we can think about there being a two-phased approach. And a strategy for acute therapy in ACS, but then developing other strategies once we know more about how to measure function for the intermediate term. And I would say for those people whose careers have been swept up in the HDL field, importantly, that I would say there's a lot of similarity here, at least from the geopolitical perspective, to the homocysteine field. And I think the last time I was here, we talked about homocysteine. And there's great similarity in that the key clinical trials failed to show the benefits that people expected, such as the case for the CTP inhibitor trials. And in part, it's a consequence of not considering the complexity of the intervention and its off-target effects or unpredicted effects. And this is the same case here. You focus on CTP because you can measure it, you understand what it does. There's an experiment of nature which suggests there's benefit if it's not fully functional. And yet, in the living, in the wild, patients with established atherosclerotic disease are much more complicated than that, and these interventions have other effects that we haven't been smart enough to explore. So I would say keep hope.
Maybe the third example is antioxidants.
Yeah, another example.
Anyway, we have many examples that we have been dreaming over many, many years. And anyway, this is, I want to give thanks to you, to the panelists, and to all of you. I think this is an interesting subject that has been dissected in the best way we could. And thank you all. Thank you.